Okay, so we're going to look at a scenario here that will result in a system of inequalities. So if we know that going in that we are going to do a system, then we know we need to be looking for two different categories of information so that we can make the two different, in this case, inequalities. Okay, so as we read this, I would split the information into one thing we're told is money values. Tatiana makes $8 mowing lawns, $12 babysitting, and she wants to make $96 total. But then we also have information about just how many hours she can work. So that's how we split up and make our two separate inequalities. One will be about money, and one will be just about hours. Okay, so we need let statements. What is it that we don't know here? We don't know how many hours she babysits or how many hours she spends mowing lawns. So those are our two let statements. It doesn't matter which is which, but you need two of them. So I'm going to let X equal hours mowing, and let Y equal hours sitting. Okay. So the information regarding the money, she makes $8 every one of these X hours that she mows. So that's 8 times X. She makes $12 each one of these hours that she babysits. So we'll add on to that 12 times Y. And we want to make at least $96. At least means 96 or more. So we want all the money that Tatiana makes to be greater or equal to 96. My other inequality, the one that people usually struggle with, is actually the easier one because it's just about hours. And that's what both of the variables are. So all I know about hours is that I can work no more than 12. So no more than means when I add the hours that I mow, or Tatiana mows, plus the hours that Tatiana babysits, it's got to be smaller or exactly 12. Okay? Don't try to force the prices, the $8 and $12, into the other inequality. You're going to use each of those numbers you're given once and only once. Okay, so to graph these, we're going to write them in slope-intercept form. So subtract 8x on both sides here. We have 12y greater than or equal to negative 8x plus 96. Divide everything by 12. Y is greater than or equal to, now negative 8 over 12 is negative 2/3. You need to keep that a fraction. Do not round it to a decimal. And plus 8. All right, so this inequality has a y-intercept of 8. Let's see, 1, 2, 3, 4, 7, 8. And a slope of negative 2/3. So down 1, 2, right 3. Let me do that again. Down 2, right 3. Down 2, right 3. Down 2, right 3. The line will be solid because this had an equal to under it. So we will make a solid line passing through these points. Now, notice I stopped my line at the x-axis and y-axis, at the intercepts, because this is actually a scenario. This represents something. The x-axis down here represents hours spent mowing, and the y-axis is hours babysitting. Neither of those can be negative values, so I don't need to extend the line into the negatives. As far as shading, again, I only trust the sign when I'm in slope-intercept form, which says greater than or equal, so I will shade above. So what we are saying here is all of these blue points, both the ones on the line and the ones I'm shading, they would provide enough money. She wanted at least $96. If she works any combination that falls in this blue region, again, including the line, that would give her enough money. It would satisfy her money goal. All right, the red inequality, the one about hours, again, we need to solve for y, so we'll subtract x on both sides and get y is less than or equal to negative 1x plus 12. That one has a y-intercept of 12, so if this was 8, we got 9, 10, 11, 12. And the slope is negative 1, so down 1, right 1, down 1, right 1. It will be another solid line because it's or equal to. And we are going to shade this one under because it's less than or equal. So everything under this line would be satisfactory as far as her hours go, meaning they don't go over her limit of 12. So our solution set to the system, which would be all of the combinations of hours that would satisfy both inequalities, would be the overlap in here, this little triangular region between the two lines. And I would include both lines as part of that because they're both solid lines. Okay. So the last part of this says list 2 possible combinations that Tatiana could work. Well, that can be any 2 points that are found in this purple region. So there's one and here's one. So let's identify those. This first one is 2, 9. The second one is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 6, 5. So what do those represent? Well, the 2, 9 represents she could work 2 hours mowing, because X is hours mowing, 2 hours mowing, and 9 hours babysitting. That's one possible solution. A second possible solution would be that 6, 5, which would mean she could mow for 6 hours and babysit for 5 hours. All right, so number 2 here, we're going to solve a system of equations, and it does not indicate any certain method that we're required to use. So we have choices. We could solve this by graphing, although I don't suggest that one. We could solve by substitution or elimination. Now, normally when I see 2 equations, both in standard form, I jump for elimination, but I want to make sure that we do at least one with substitution and at least one with elimination. So I'm going to go ahead and use a substitution right here on this first one. And again, with substitution, I look through the 4 variables, both x's, both y's, and I choose one of those that I think would be simple to isolate, to solve for. And I think this x in the second equation is the simplest thing to isolate because it doesn't have a coefficient of its own. So I'm one step away from having x by itself. I just subtract 2y. So x is equal to negative 2y minus 4/3. And That is the step that I've suggested you put in a box. Okay. So what did we do with that box? That was to identify the value that we would substitute into the other equation. Now, since I solve for x, it's the x I'll be replacing in the other equation. So 3 times everything in the box, so negative 2y minus 4/3, and please keep the negative 4/3. Do not try to change it into a decimal. It's a repeating decimal, and we don't like to round when it's not necessary. Okay, then I still have plus 5y equals negative 3. And now we have an equation that, yes, it's a little bit longer, but I have only one variable in it. It's just y. There are no x's left in this. So my first step will be to distribute. So 3 times negative 2y is negative 6y. 3 times negative 4/3 is negative 4. So see, that fraction ended up disappearing anyway. And then I have plus 5y equals negative 3. I have some like terms here. Negative 6y and positive 5y make negative 1y. Still have a minus 4 there with it, equals negative 3. Add 4 to both sides, so negative 1y equals positive 1. To get rid of that negative 1 coefficient, you divide both sides by negative 1, and y is negative 1. Now remember, that's only half of the solution. The solution to a system is a point. So in order to solve for the other variable, I just take this first one, in this case it's a y, and I substitute that back in the box. So x is equal to negative 2 times the value I just found, negative 1, minus 4/3. X is equal to, this is positive 2 minus 4/3. Now, again, feel free to use your calculator, but I'll go over here on the side and just remind you how we subtract fractions. This is really 2 over 1 minus 4/3. We would have to get common denominators, which the common denominator for 1 and 3 is 3. So, since I multiplied this denominator by 3, I have to do that to the numerator, that's 6/3. And this one, I don't need to change at all. So 6/3 minus 4/3 is 2/3. So x is equal to 2/3. Again, do not round. We don't want 0.6 or 0.7. It's 2/3. So my solution here is the point 2/3, negative 1. Okay, number 3. Again, I have both equations in standard form. So this time I will go ahead and use elimination. Now, we could very easily multiply this top equation by negative 2, and it would make opposites with the x's. But if you're actually looking ahead and looking at the whole problem, if you instead multiplied it by 5 to make the y's opposite, that's going to cancel the denominator of this fraction here. And then you accidentally, or just by convenience, it also it makes opposites and takes away the fraction in the problem. So if I multiply the top equation here by 5, it turns into 5x minus 5y equals, now 5 times negative 12 over 5 is just the negative 12. And there I have my two equations, the bottom one and the new one, to add together. So 2x and 5x make 7x. The 5y and negative 5y are eliminated. And that is equal to negative 2 and negative 12 is negative 14. Divide both sides by 7. X is equal to negative 2. I need to substitute that back into any of the original equations. I'm going to use this one, 2x plus 5y equals negative 2, because let's be truthful, nobody wants to use this fraction if you don't have to. So that's 2 times negative 2 plus 5y equals negative 2. 2 times negative 2 is negative 4. plus 5y is negative 2. Add 4 to both sides. So 5y is equal to 2. Divide both sides by 5. And y is equal to, I like the answer 2/5, but this one, it is okay to divide. It's a nice, neat terminating decimal. It's 0.4. Okay, so my solution is negative 2 2/5. All right, now number 4 is also going to result in a system of equations, but we're going to have to make our own, okay? So the sum of two numbers is 70, and the difference is 11. What are the numbers? So my question is, I need to find these numbers that were added, because sum means addition, and subtracted, difference means subtraction. So the unknowns are the actual numbers themselves. So it doesn't matter what you actually call them, as long as you realize what your x and y stand for. So let's just say x is the first number, and y will be the second number. Or you could call them the large number and the small number. Okay, so we have, whenever we do these systems of equations from a word problem, from a scenario, we have to think about what are the two different kinds of information that we have here. And in this case, it's just simply that once they were added, so that will give me one equation, and then later they were subtracted, so that gives me another equation. So when they are added, when these two numbers I don't know, x and y, are added, their sum is 70. But then when they are subtracted, those same two numbers that I don't know, when I subtract them, I get 11. This system is just screaming out for the elimination method because the y and negative y are already opposites. So I can just add them right now as is. So x plus x is 2x, y and negative y is canceled. 70 and 11 is 81. Divide both sides by 2. X is, you could have 81 over 2, or, again, this is a terminating decimal, feel free to use it, it's 40.5. So that's one of the numbers. Now that's probably not what you expected. I would imagine that you would have expected two integers. I kind of did myself, but this should not be a big problem. I need to substitute that back into one of the originals. I'm going to stick with the one that doesn't have any subtraction in it. So x is 40.5 plus y makes 70. So one-step problem to solve, subtract 40.5 from both sides. Y is 29.5. So if the decimals felt a little weird to you, try it out. When you add 40.5 and 29.5, does it equal 70? Is 40.5 plus 29.5 70? Yes. What about when I subtract them? What is 40.5 minus 29.5? That's supposed to be 11. It is. So it checks out. They work. So the numbers are 40.5 and 29.5. Okay, of the two non-right angles in a right triangle, and they are labeled, they're marked X and Y, so that's sort of like doing our let statements. The picture counts as your let statements. One measures twice as many degrees as the other. What are the angles? Now, this one might feel like it's only giving you one bit of information, but you know certain things about a triangle. All three angles in a triangle, the sum of all three angles is 180. Well, this one marked as a right angle is 90 degrees. So if I take that away from the total, 180 degrees minus 90 degrees leaves me 90 degrees for the sum of these two. So one of my equations is that these two remaining angles, the ones labeled X and Y, they have to add up to 90. Now, the other piece of information is in the question. One of those angles measures twice as many as the other. Now, in this case, pictures are not necessarily drawn to scale, so I can't say for sure whether X or Y is larger, but it does look like the Y is the larger one. Okay, so I'll go ahead and treat it that way. So one measures twice as much as the other. That would mean the large one, Y, is, in math we turn the word is into equals, twice the other one, so twice the smaller one. So that means twice is times 2. Right? So the two non-right angles add up to 90. That's one equation. And then the larger of the two is exactly twice the smaller one. This system of equations, they are not both in standard form. This one, I feel, is begging for you to use substitution because we already have a variable right here that's isolated. So I'm ready to go ahead and put a box around that and then just substitute it into the other problem. So this first equation, this green one, turns into x plus, I replace y with 2x, equals 90. So 1x plus 2x is 3x, equals 90. Divide both sides by 3, x is equal to 30. So this smaller angle here is 30 degrees. Substitute that number back in the box. 2 times 30 is y, so that's 60 degrees. So the y is 60 degrees. Those two do add to 90, and one of them is twice the other. And number 6, rectangular field is enclosed by a fence on 3 sides. So fence, 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 and a wall on the 4th side. The total length of the fence is 320, and the total perimeter of the field is 400. Okay, what are the dimensions? Dimensions, when you're asked for dimensions, that's always asking you, what are the length and the width? What are the measurements? Okay, so that's what we are to find here. And again, since there is a picture, the length and width are the variables, and they're already defined for us. The length here is x, and the width is y, or base and height, if you prefer. Now, since we are told that this is a rectangle, you're familiar with the properties of a rectangle. If this side is a length of x, then the bottom is also a length of x. If this short side is y, then the length of this side where the wall is also y. So the total length of the fence is 320. Well, the fence goes around 3 of these sides. So my equation regarding the fence, I would have a side that's x plus a side that's y plus a side that's x again. So top, left, and bottom, they have to add to 320. Well, I could simplify that. 1x and 1x is 2x plus y equals 320. That's one of my equations. Now then I'm told that the perimeter is 400. Perimeter is when you add up the lengths of all the sides. So for perimeter, I would say I have 2 sides that are x and 2 sides that are y, and that adds up to 400. So as I look at these 2 equations, my system, I feel like elimination would probably be the simplest way to go about solving here. And if I multiplied the top or bottom by -1, my x's would be opposites. So I'm going to multiply that top equation by -1. It will turn into -2x minus y is equal to -320. Add these, the pink and the green. The x's are eliminated. 2y and -y is y. 400 and -320 is 80. So y, which is the short side here, is 80 yards. How do I find the length? Well, I just need to substitute that 80 into any of the other equations. I'll choose this original one I wrote in black, the one about the fencing. So 2 times x plus y we know is 80 has to equal 320. Subtract 80 on both sides. So 2x is equal to 240. Divide by 2. X is 120. So 120 yards. So my dimensions, my length and width are 120 yards by 80 yards. Okay, number 7 says a ray cuts a line forming 2 angles. They're already labeled as angle with a measurement of x degrees and an angle with a measurement of y degrees. The difference between the 2 angles is 18 degrees. So the difference means when I subtract the 2 angles, I get 18. So that can give me one equation right there. Now, which angle you put first in the subtraction problem is really up to you. Again, you don't want to trust the picture, the way it's drawn. They're not supposed to be to scale. But in the picture, it does look like the angle with the y is larger. So I would say the larger angle minus the smaller angle has to equal 18 degrees. So where am I supposed to come up with another equation? That's the only bit of information I was given. Well, not really. We were told that that ray is cutting a line, that this was a line, not just close to a line, it is straight. So that means the measurement in degrees of a line is 180, so that when I put x and y together, this entire angle is 180 degrees. So the other equation will be x plus y equals 180. Now, those are, one's in standard form, one is almost in standard form. So I can just rearrange this blue one and rewrite it as negative x plus y equals 18, so that the x's and y's line up, and I can go ahead and use elimination on this system. So x and negative x is eliminated. Y and another y makes 2y. 180 and 18 makes 198. Divide both sides by 2. Y is equal to 99. So what's the value of x? Well, substitute the 99 into either of your equations. I'll put it right in here. So x plus 99 equals 180. Subtract 99 on both sides. X is equal to 81 degrees. So this is 81 degrees. This is 99 degrees.